the chain rule. Sebastian, please explain to us what the chain rule is.
Well, Juan Diego, for any composition of functions, for example, f of g of x, the derivative will be f prime of g of x times g prime of x.
Now this chain rule will help us, as Sebastian just said, find the derivative of a composition of functions. But to do that, we must have some derivative shortcuts so that those make the process much easier. And we can prove these, but it would be way too long to include in such a short video. So we'll just describe them to you. The first one is x to the power of n. And for a long complicated reason, if you find the derivative of this function, we find that n, which is the coefficient, times x to the power of n minus 1, is the derivative of the original function. Now next, we'll skip this one, we'll refer back to it. The derivative of a function, c in this case, is just 0, because if you graph it, we find that c is just a straight line, and the slope of a straight line is 0. Now let's go back to this one. The derivative of x is 1. Why? Because if we plug in x on a linear equation function, it means that there is no y-intercept, and that m, in this case, which we do not mention it because it's 1, which is the slope, and the slope of x, in this case, would be just 1. Mx plus b, well, derivative is a slope, so the derivative of a linear function is just the slope. Next, we have a summation or a subtraction of derivatives, and that just translates. The sum of two functions is just the sum of the two of the function's derivatives. Next, we have a coefficient times a function, and the similar thing occurs. The coefficient times a function, the derivative of this would be the coefficient times the derivative of the function. Then we have the trigonometric shortcuts. The derivative of sine is just cosine, for a complicated reason which we don't have time to explain, and a similar but not so similar thing happens with cosine. The derivative of cosine is just negative x. Sebastian, please kick off the examples.
Examples. For these examples, find the derivative of the function. So, f of x in this case is negative 5x to the power of negative 7 over 3. Here we have a composition of two functions. First we have a constant times a function. And then we have x to the power of n, which would be x to the power of n being negative 7 over 3. And the constant being negative 5. So first we will get the derivative of x to the power of n, which is simply n times x to the power of n minus 1. In this case 1 is 3 over 3. So negative 3 over 3 minus negative 7 over 3 would be negative 10 over 3 to the power of x. Now, we do negative 7 over 3 times 5, which in this case would be 35 over 3, since the negatives cancel out. And 5 times 7 is 35 over 3. Then we put x to a power of negative 10 over 3. Now that would be the derivative of this function. However, since we're planning to simplify them, the simplification of this is simply removing the negative exponent, which would be just passing it down to the denominator and removing the negative from the exponent. So it would be 35 over 3x to the power of negative 10 over 3, and of course over 1, but 35 times 1 is just 1.
Thank you, Sebastian. Let's move on to the next example. Example 2. We're given that the function is the cosine of the sine of x. Well, and we have trigonometric functions. We'll use the trigonometric shortcuts. We know the outermost function is cosine, and we find that the derivative of cosine is simply negative sine. Then the inner function is sine. The derivative of sine is cosine. So we'll follow the chain rule. The derivative of the outermost function times x, which is sine of x in this case, times the derivative of the inner function, which is sine, and the derivative of sine is just cosine. We have this expression which can already be said that is the derivative of the original function, but we'll simplify it a little bit. and that gives us negative sine of the sine of x times the cosine of x.
Ultimately, we have the monster function. We have sine squared of cosine squared of x, which will include a function within a function within a function within a function within a function. Yeah. So here we have various functions within functions. The first one would be the squared of the sine, then it would be the sine, then the squared of the cosine, then the cosine, and ultimately x. But from the given on the back of the page, we know that the derivative of x is simply 1, so we can just ignore that. Now, for the first part, we will get the derivative of squared. So this would simply be x to the power of n, which will result in n, which is 2, times x, which in this case is sine, then n minus 1, which is simply 1, so there should be a 1 here, but we ignore it. So 2 times the sine of the whole expression, which would be cosine squared of x. Okay, then we get the derivative of sine, which is simply cosine, but still we put cosine of the whole expression, which would be cosine squared of x. Then we get the derivative of this squared for cosine, which is the same as the first part, which is put 2 times the cosine of x, since it is multiplying times the whole expression. Ultimately, we get the derivative of cosine, which is just negative sine of x, of course. And then we would have the derivative of x, which is just 1, but we just ignore that. So this part here is already the derivative of this function. However, since we're looking for simplification, we will try to cluster together like terms. In this case, the sines and the cosines. We put the sines here and the cosines together. However, we discover when we try to factor out the sines that it would be rather simpler to simply leave it like that. So we just multiply the numbers, which would be 2 times 2 times negative 1 here. We got negative 4. And place the simplest functions first, which would be sine of x and cosine of x. So we put negative 4 times the sine of x times the cosine of x times the sine of the cosine squared of x times the cosine of the cosine squared of x.
Thank you, Sebastian.